Hey everyone. So today we are going to solve few numericals related to thermal expansion. So we are supposed to solve 8 questions related to thermal expansion, which includes linear expansion, superficial expansion, and few of the tricky questions related to volumetric expansion. So let's see question number 1. A length of the pipe is 50 meter. So we are also going to simultaneously write the datas which are given to us. So question number 1 states that the length of the pipe is 50 meter. Its initial temperature is 16 degree, and when the hot liquid flows through the pipe, its temperature rises to this. So this is final temperature, that is 80 degree. So I know what is rise in temperature, final minus initial, so that is 64 degrees Celsius. Coefficient of linear expansion is alpha, that is given to us as 29 into 10 raised to minus 6. 1 upon degree Celsius or 1 upon degree Kelvin, it does not matter. So it is given 1 upon Kelvin, but since it is difference in temperature included over here, so I can also write it down this as 1 upon degree Celsius. It doesn't matter, right? Okay. Now what we are supposed to find out? So the pipe elongates, or you are supposed to find out the final length of the pipe. So what has happened over here is, this was the situation. The pipe was 50 meters long, so this is L0. When we passed the hot liquid, the pipe length increased. So say this is the new length. So old length minus new length, say that is L dash, that is delta L. And we know delta L is equal to L0 alpha delta T. So I am going to substitute all the values over here. L0 is 50 meter into alpha value is 29 into 10 raised to minus 6, 1 upon degree Celsius, into delta T is 64 degrees Celsius. Degree Celsius getting cancelled. So my final answer is going to come in meter. So 50 multiplied by 29 multiplied by 64, that is given to us as 92800 into 10 raised to minus 6. Only the unit left is meter. So which means if I shift 1, 2, 3, 4, 5, then 5 zeros will be getting cancelled from here, or in short I can also write down 0.0928 into 10 raised to plus 6, because this can be written like this, multiply by this, 10 raised to minus 6 remains as it is. So this is 0.0928 meter. Multiplication of the bases, if the bases are same, power gets added up. So my final answer would be 0.0928 meter. This is the increase in the length. So the final length L dash, that is equal to the old length plus increase in the length. So 50 plus 0.0928. So my delta L value is equal to 50.0928 meter. So this is the solution to problem number 1. Let me highlight this. This is question number 1. Now in question number 2, what we are given is, a rod of metal is measured at this temperature, and its temperature is, initial temperature and the length are given to us. So initial temperature is this, and it is 3 meter long. So question number 2, initial temperature of the rod is 273 Kelvin. Initial length of the rod, that we call it as L0, that is equal to 3 meter. Now at 373, so we are given the final temperature. That means the final temperature is more, so we are heating the rod. Rise in temperature is final minus initial. Alpha is supposed to be found out, and the final length of the rod L dash is equal to 3.01 meter. So initial length of the rod, final length of the rod. So change in the length or increase in the length is final minus initial, that is 0.01 meter. So I am going to apply this formula again. Delta L is equal to L0 alpha delta T, and since delta L is given, delta T is given, L0 is given, we are supposed to find out alpha, what is coefficient of linear expansion. So alpha is equal to delta L, these two are in multiplication, they will go here in division, upon L0 into delta T. So alpha is equal to delta L is 0.01 meter upon L0 is equal to 3 meter. So meter getting cancelled, multiply by delta T is 100 Kelvin. Now this alpha is actually equal to, this can be written as 1 upon 100. So 1 upon 100 into this 100. So this is 1 upon 3 into 1000. 10,000 because 1 upon 100 into this 100. And this, its unit would be Kelvin raised to minus 1. So my final answer would be 1 by 3 0.33 into 10 raised to 4, which goes up to become 10 raised to minus 4. And the unit would be Kelvin raised to minus 1. So this is our answer, right? And if you shift 2 decimals over here, this will become 10 raised to minus 6. So if I want to make this as 33, then this would be 10 raised to minus 6, which is our answer, right? So again, now let's move on to the third problem. So third problem states that we have a copper transmission line. Transmission lines means the overhead cables which carry electricity. So they are called transmission lines. They have length 40 meter. So its initial length is 40 meter. Initial temperature is 20 degrees Celsius. Then at 50 degrees, so the temperature of that cable would have gone high due to, say, high temperature in summer, due to which the expansion in the length would have taken place, and that delta L we are supposed to find out. So delta L is equal to, again, L0 alpha delta T. L0 value we are well aware about, 40 meter into 17 into 10 raised to minus 6, 1 upon degree Celsius or Kelvin, doesn't matter, multiply by delta T is increase in the temperature. So final temperature minus initial temperature is 30 degrees Celsius. So 30 degrees Celsius, degree C getting cancelled. So delta L is equal to 40 multiplied by 17 multiplied by 30 is this. So it is 20400 10 raised to minus 6, and the only unit left is meter. So if I shift 1 2 3 4 5 and then 6, it is 0.024 meter, and this 10 raised to minus 6 would be getting cancelled over there, right? So my final answer delta L is this 0.024 meter. You can check by yourself, right? Okay, so let's move on to the next part of the problem. So question number 4 says that a brass tape measuring this, so that means the initial length of the brass cap is given. So question number 4, and initial length L0 is given to us as 2.10 meter. Its initial temperature is 15 degrees Celsius. Alpha is given to us as 18 into 10 raised to minus 6, 1 upon degree Celsius, degree Kelvin, doesn't matter. We are supposed to find out delta L in the first part. Delta L if delta T, or if the final temperature is this. So final temperature TF is 40 degrees Celsius. So I know now what is the difference in temperature, final minus initial. So delta L is equal to alpha L0 delta T. Alpha value is 18 into 10 raised to minus 6, 1 upon degree Celsius. L0 is 2.1 meter. Multiply by this increase in the temperature is 40 and 15. So this is 25 degrees Celsius. Degree C getting cancelled. So now let me multiply this. So 18 into 2.1, 18 multiplied by 2.1 multiplied by 25 is 945, right? So my answer here would be 945 into 10 raised to minus 6 meter. So this is 945 into 10 raised to minus 6 meter. That means 3 decimals from here if I shift, so it will become 0.945 into 10 raised to minus 3 meter. And again if I shift 3 zeros more, I can keep on slashing the zeros from here and keep on shifting the decimals to the left hand side. So 3 more zeros over here. And finally I am done, and all these zeros now are gone, right? So this is our final answer. So 0.000945 meter is our answer, right? Make sure that you are writing proper units and all those things. So this is delta L. Now let's solve the B part. Now in B part, suppose if I tell you the initial length of the rod was L1, then it increased to L2. Then if I want to find out percentage increase in length of rod, this is the formula: final length minus initial length upon initial length multiplied by 100%. This is the formula. So final minus initial length is delta L upon L1 into 100%. So I have already found out what is delta L, that is 0.000945 divided by initial length was 2.1. This will be without unit because its meter and this meter are going to get cancelled. Multiply by 100%. So if I multiply, this would be 2 zeros on this side, so 0.120945 upon 2.1, that is equal to, so that means 0.945 divided by 2.1 is 0.45%, right? So 0.45% is the increase in the length percentage wise, correct? Okay, now moving on to problem number 5. So we are given a steel railway line of length this. So we know the initial length has 30 meter and its temperature, initial temperature is 288 Kelvin. Then it is finally heated 2. So this means final temperature is 303 Kelvin. So rise in temperature is final minus initial. So it was 12 and 3, so it is 15 Kelvin or 15 degrees Celsius. Delta T doesn't matter because if you subtract 273 from both, and even though if you find out the difference in temperature, doesn't matter. So that means here the value of alpha is given to us as 15 into 10 raised to minus 6, 1 upon Kelvin, correct? So if I apply the formula, we are supposed to find out delta L. So delta L is equal to L0 alpha delta T. So L0 is 30 meter into 15 into 10 raised to minus 6, 1 upon Kelvin, multiply by 15 Kelvin. So Kelvin got cancelled. 15 15s are 225. So 225 multiplied by 30. 225 multiplied by 30 is 6750. So 6750 multiplied by 10 raised to minus 6, and the only unit left is meter. So 4 zeros from here would be striked out. So 0.00675 meter would be my answer, because 4 zeros from here and another 2 zeros would be added, then and only then I can remove these 6 zeros, correct? So my answer delta L is this. Now let's move on to the next problem. that is a problem related to the superficial expansion. So we have a plate and its area is this. So I always ask my viewer that while you are actually reading the question, make sure you are also writing down the things. So it would be more beneficial in understanding how to solve a numerical. So your initial area is given as 800 millimeter square. Then initial temperature is 15 degrees Celsius. Final temperature is 100 degrees Celsius. So delta T difference in the temperature is 85 degrees Celsius. And coefficient of linear expansion is 19 into 10 raised to minus 6 1 upon Kelvin, and we are supposed to find out the increase in the area delta A. So we know that delta A is equal to A0 into beta into delta T, but the problem here is we are not given what is beta, but we are anyhow given the value of alpha, and we have already learned that beta is twice of alpha. So what am I going to do is, instead of A0, no need to convert this into meter square, 800 millimeter square, multiply by 19 to the 38, because this is alpha, 10 raised to minus 6 1 upon Kelvin, into delta T is 85. This can be also written as degrees Celsius getting cancelled. So 800 multiply by 38 multiply by 85 is this, right? So we have 2584,000 into 10 raised to minus 6, and the unit would be, the only unit left is millimeter square. So if I start removing 6 zeros from here, because here is the decimal, 1 2 3 4 5 6, so my answer would be 2.584 mm square. Now if I still want to convert this into meter square, so 2.584 into 10 raised to minus 6 mm square, sorry, now it would be meter square. This would be my answer, because 1 millimeter square is equal to 10 raised to minus 6 meter square. So this is our final answer. So we have calculated the value of delta A as well. So moving on to the problem number 7, we have a brass shaft of this diameter. It has to be inserted inside a hole of this diameter. So actually the brass shaft is bigger and the hole is smaller. So we have to cool this brass shaft when we are supposed to put this inside this hole. Alpha is given to us, coefficient of linear expansion, and we are supposed to find out what is the temperature by which we have to cool it down. Initial temperature is not given, final is not given, so we just have to find out delta T, right? So I would like to tell all the viewers that sometimes people get confused by applying the concept of superficial expansion, but let me try to explain you by a different way. Suppose this is a hole, the inside part, but I am actually considering a very thin strip around the hole, very thin strip, and if I fold the thin strip, it becomes a hole of this diameter. Now if I actually cut this strip from here and make it straight like this, then the hole actually vanishes. So this hole is actually formed when I make this strip round, but when I cut and make the strip straight, the length of this strip is, say, L1 would be equal to pi times d1, because when I cut it and make straight, then the length of this circle is the circumference, which itself will become the length, correct? And this shaft is again hollow from here and its diameter is bigger than this one. So if I again cut this shaft and make it straight just like this, this is, if I cut it from here and make it straight like this one, the length would be again equal to circumference. Let me call this length as L2. That is equal to 2 pi r, but 2r is d, so pi times d2. This is length L2, correct? Now when I cool this has to be inserted inside this one, But for theoretical purposes, I am going to cool in such a way that its diameter decreases and just becomes equal to d1. Viewers might be thinking that okay, if we cool this and if we make the diameter this equal to this one, it is not going to go inside. I do agree with you, but we have to cool in such a way that theoretically the diameter becomes equal. Yeah, practically we have to slightly decrease the diameter more than d1, but by how much amount, that we don't know. So for theoretical purposes, we are going to consider that this diameter has to be made equal to d1, or we can also say that this length and this length, if it becomes equal, or if I shorten this length to this one, then also it can be inserted inside. So now what I have is, this is L1, that is pi times d1, and this is pi times d2 till here. And then if I cool this lower rod by this length, final length would become over here. So this L1 is the final length that I want to reach. L2 is the initial length. So L2 minus L1 would be delta L. Correct. So if I apply the formula, delta L is equal to L0 alpha delta T. I don't know what is delta T, but I do know what is L0. L0 is the length which you are initially operating with. So if you are heating or cooling any length, that will become L0. So I am cooling this bottom length. So this becomes pi times d2 multiplied by alpha of the rod is equal to 18 into 10 raised to minus 6 into delta T, that is equal to delta L. So delta is L2 minus L1. But L2 minus L1 can be written as pi common d2 minus d1, because this is pi d2 minus pi d1, so pi comes out to be common. Pi times d2 into 18 into 10 raised to minus 6 into delta T. Now I am going to substitute the value. D2 is 15.02 mm minus 15 mm, so mm again is common, that is equal to pi times 15.02 mm into, this is 18 into 10 raised to minus 6, 1 upon degree Celsius into delta T. So this degree Celsius will go up over here, and this pi and pi are anyhow going to get cancelled. So this is 0.2. So 0.2 mm also gets cancelled, so I need not to write down mm again. So 0.2 upon, now these two are in multiplication, they will go here in division. So it is 15.02 into 18 into 10 raised to minus 6 is equal to delta T. Now this degree Celsius was in division, it will go up in multiplication like this, and delta T is equal to 0.2 multiplied by 10 raised to minus 6 goes up to become 10 raised to 6 upon 15.02 into 18. So I am supposed to shift 6 zeros on this side. So this will become 0. I'm sorry, I have made a mistake. This is 15.02. So here it would be 0.02. 0.02. So 0. Again 02. So 0.02 into 10 raised to 6 is 1, 2, 3, 4. 20,000 degree C is anyhow attached over here. 15.02 into 18. So let us find out this. 20,000 divided by 15.02 is equal to, again divided by 18. So my answer is 73.9. So approximately this can be written as 74 degrees Celsius. That is the rise in the temperature. I'm sorry, this is the cooling down the temperature. So since we are cooling this temperature, so whatever the initial temperature of this may be, we are cooling it by 74 degree Kelvin or Celsius, doesn't matter. So we reach finally over here. So the last problem goes as under. This is question number 8, the last one. The initial temperature is 283 Kelvin, and this is a problem of volumetric expansion. So initial volume is given to us as 440 mm cube. Then we are heating it and the final volume becomes 480 mm cube. The coefficient of cubic expansion given to us, that is gamma, that is 12 into 10 raised to minus 4, 1 upon degree Kelvin or degree Celsius, doesn't matter. So we are supposed to find out, we have this formula delta V is equal to V0 into gamma into delta T. So we are supposed to find out final temperature because we are heating it to some temperature. This is the volume at this temperature, but this is the volume at final temperature. We don't know that. So change in volume is final minus initial. So since the mercury is expanding, we are heating it. So the final temperature should be more than this one. So change in volume is equal to this minus this, that is 40 mm cube, multiplied by V0 is initial volume, 440 mm cube, sorry, that is equal to V0 into gamma is 12 into 10 raised to minus 4, 1 upon degree Celsius into delta T. Now this millimeter cube is going to get cancelled. This degree Celsius will go up over there. So 40 into degree Celsius, and this is in multiplication, it will come here in division. So 440 into 12 into 10 raised to minus 4 is my delta T. So this 0 0 getting cancelled, and 4 upon 44 into 12 into 10 raised to plus 4, because minus 4 going up, that would be in degree Celsius delta T. So delta T again, that is equal to 4 upon 44 into 12. 44 into 12 is 528. 528 into 1, 2, 3, 4 degrees Celsius. So this is 40,000 divided by 528. So 40,000 divided by 528 is this, correct? So this is delta T, 75.7. So 75.7 degrees Celsius is my delta T, or I can also write down this in Kelvin. So 75.7 Kelvin, which is the rise in temperature because the final volume is increasing. This was initial temperature, this is rise in temperature. So final temperature would be this, initial plus delta T, rise in temperature. So final temperature is equal to 283 plus 75.7, that is 358.7 degree Celsius. Because you can write down this in degree Celsius Kelvin, oh, I'm sorry, this is in Kelvin, I'm sorry, because 283 was in Kelvin and this is in Kelvin, so final answer is this. So hopefully guys you have enjoyed the explanation. Do subscribe to my channel. Thanks for watching the video. Comment in the comment section if you got any doubts.